Okay, class, today we are going to be talking about arc length. And arc length is just a portion of a circle. It is part of the circumference of a circle. So if you have a circle, and I have my diagram down below, if you have a circle with radius r and your central angle theta, and your theta is going to be measured in radians, so we're going to have to make sure our theta is in radians. Then our arc length, which is this portion of the circle here, which is going to be called S. So you can see S, or arc length, is just part of the circumference of the circle. So if we're looking at this sector, we have the radius r, the central angle theta, and the arc length S. So we can use the formula S is r theta, or likewise, if we solved for theta, theta is S over r. So these are just, it's the same formula written two different ways, where r is the radius of the circle, S is the arc length of the circle, and theta is our angle measured in radians. So in the first example, we want to find the central angle, which is our theta, with the radius, or our r, is 1.7 feet. That intercepts an arc length of 2.5 feet, so that is our S. So we want to find theta, so I'm going to go ahead and use the formula written as theta is S over r, and I'm just going to plug in what I know. S is 2.5 feet, and my r is 1.7 feet. It's the same unit, so I don't need to do any unit conversions. When I divide 2.5 over 1.7, I get 1.47, and these are radians because our angle theta is given in radians. In the second part, it says, second question, it says, find the radius of the circle shown. So I know that my central angle theta is 47 degrees, and I'm given my arc length of 5.6 centimeters, and I want to find the radius, or find r. So we have one additional step before we can plug into our formula theta equals S over r, because our theta was given in degrees, so we're going to have to first convert this to radians. So in order to convert from degrees to radians, we're going to use the conversion factor. 180 degrees is pi radians. So let's go ahead and set that up, conversions. So here is my set up conversion factor. I know that theta is 47 degrees, and so I'm going to take my 47 degrees and multiply it by the conversion factor, where pi radians is 180 degrees. And my degrees are going to be canceled, and I'm left with 47 pi radians over 180 degrees. So now I'm going to go ahead and plug what I know. I know my theta, and I know my S, and I'm going to go ahead and find my r. So the formula given is that S is r theta, and since I want to find the radius, I'm going to solve this for r by dividing both sides by theta. When I divide both sides by theta, they cancel on the right-hand side, and I'm left with r equals S over theta. So I'm just going to plug in my S is 5.6, and my theta is 47 pi radians over 180. And I'm going to use this whole number and not its reduced and simplified answer, because I want to get the exact answer at the end. So I just plug it straight in, and I need to make sure that when I plug this into my calculator, I'm going to use parentheses over the whole denominator. So I'm going to do 5.6 divided by the entire denominator. And since I'm going to find the radius, my units is going to be our centimeters, and I get my r is 6.83 centimeters. So in general, as a class, we're going to round to 2 decimal places unless it's stated otherwise. And if you're ever unsure, just go ahead and ask me in class. If you did not get an answer when you're following along in your calculator of 6.83, make sure I go over how to properly input this into your calculator in class tomorrow. So let's go ahead and move on to the next problem, which is an application. It says, what's the distance in miles between San Francisco and Seattle? If San Francisco has a latitude of 37 degrees 46 minutes and 39 seconds, and Seattle has a latitude of 47 degrees 36 minutes and 32 seconds. And we're going to use that the approximate radius of the Earth is 4,000. So I know the approximate radius, so I have my R, and I need to find the distance in miles between San Francisco and Seattle. So if you recall, San Francisco and Seattle are both on the Earth. Okay, so there's my little globe, and we're in the northern hemisphere. So let's just really exaggerate this, but here is San Francisco, let's say, and Seattle is due north for the most part of San Francisco. It's just north of us. So this is a huge exaggeration. But on the globe, on the edge of it, right, the Earth, we have the two cities, and this arc length here, the distance between the two cities is really an arc length. It's this curvature. We're not looking at a flat map. We're thinking of on the Earth, what's the distance? So I know my two latitudes, so I'm going to draw in the center of the Earth and my two latitudes. Remember, the latitude goes from the equator up to that angle. So let me go ahead and draw that in. Okay, so I jumped ahead and drew a little diagram in. So I have my center of my Earth here, that's marked in the center, and I have kind of my equator line. Think of it as my central angle, my positive x-axis. If I go up to my San Francisco here, San Francisco is the southern city, this angle of elevation here that I marked in red is my 37-degree angle. Then my other angle is my green angle, and my green angle is my angle of elevation up to Seattle, which I'm going to abbreviate SEA. And that also is from this positive x-axis or the equator all the way up to where Seattle is right here. So this big green angle is my 47-degree angle. So I have my two angle thetas. Now really what I'm going to be looking at, if I switch over to my highlighter, is a sector, a piece of this. So it's just going to be a piece of the section of the Earth. It's from between Seattle and San Francisco, and then my arc length. I'm just looking at that little piece there. And so remember, when we're going to use the arc length formula, we need to know our central angle theta, and our central angle theta is going to be the angle between my two highlighted marks. It's just this black area. This is going to be my theta, which I'm going to have to find. And I know that my big green angle, and if I subtract off my red angle, I'm going to be left with this black angle, which is the theta that I'm going to want. So I'm going to find my theta by subtracting my two angles. I ultimately want to know my arc length, which is my S, and I know that the radius of the Earth, which is these long blue ones, is my 4,000 miles. So I know that I am going to be using the arc length formula. I'm going to have to start off by finding theta, which is the difference between the two angles. So I'm going to subtract these two, and I'm going to go ahead and do that on my calculator. And once I subtract the two angles, my theta will need to be converted into radians. So let's go ahead and set up finding theta. So we have that theta is our bigger angle, the 47 degrees, minus the smaller angle, the 37 degrees. So we're going to put this in. We need to use the angle menu. Remember that second apps to get to the angle menu so that we can do the degrees and minutes. And we use the alpha key to get the seconds symbol. So if you need help entering the degrees, minutes, and seconds into your calculator, please, I can assist you in class. So we're going to subtract the two, and we get that theta is, when we convert it to degrees, minutes, and seconds, is 9 degrees, 49 minutes, and 37 seconds. So we have that this is our theta in degrees, but remember we ultimately want to find the arc length. So we're going to have to convert our theta from degrees to radians using our conversion factor. So if I have my angle in degrees and multiply it by pi radians over 180 degrees, my degrees are going to cancel, and I'm left with about 0.1759 radians. I wrote the whole thing out because I'm just going to use this number that's in my calculator in our next calculation. So remember, we want to find the distance between San Francisco and Seattle, which is our arc length. It's our S. And the formula for arc length is S equals R theta. Our R was given as 4,000 miles, and our theta we just found in radians. And remember, we had to first find the difference of the angles in degrees and then convert it to radians in order to use our formula. So I'm just going to plug our 4,000 and our 0.1759 in for our theta, and I multiply those two numbers. And again, I'm not using just this abbreviated version. I'm using this whole thing in my calculator and multiplying it by 4,000, and I get approximately 686 miles. I didn't round. It really is, you know, I wanted to find the distance in miles approximately. How far it is. So this tells us that if we approximate the radius of the Earth to be 4,000, now the radius of the Earth isn't exactly 4,000. This is all an approximation here. The distance from San Francisco to Seattle, if we went, of course, in a straight line, is about 686 miles. Okay, there you have it. That is all that we're going to get through. I will see you in class.